Okay, in this video, I'm going to show you how to solve square root equations. Just a couple things to remember before we actually start. Recall that the square root of x is the same as x to the power of 1/2. Okay, this goes back to those root properties. So, like for example, the cube root. Let me get my pen. The cube root of x is the same as x to the 1/3. Okay, the fourth root is the same as 1/4, and so forth. We're not gonna do those right now. For today's video, just make sure you understand the 1/2 property, okay? Anyway, so another thing you need to recall is that the inverse of the square root of x is x squared. So if I want to get rid of a square root, we square something. And the reason we do it is because if we use this property where we have the 1/2, okay, if I square that, so if I put that little 2 here, 2 times 1/2 is just 1, so we end up with x, which gets rid of that square root for us, okay? So we're going to go ahead and start solving some problems. We have that the square root of x minus 5 is equal to 7. So to solve something like this, you can draw your line if you want to, okay? We will square both sides because there's nothing in front, nothing behind it or below it, so we can square right away this entire thing here, and we're going to square this side as well, okay? And the reason I'm putting parentheses is because sometimes you'll have a bigger term than just a 7 or just one variable. So this will cancel on this side, it'll get rid of it, and we'll be left with x minus 5 is equal to 7 squared is the same as 7 times 7. You want to write that down in case you don't know. Okay, that's 7 times 7, which is just 49. Okay, so from there, it's a simple linear algebraic equation. So plus 5 plus 5, and so x is equal to 54 in this case. And that's it. That's it for a simple one like this. Okay. For example number 2, we have an extra step. Notice that we have our little square root, and then we have minus 2 on the outside. So before we can do any kind of squaring, we have to get rid of this minus 2 here. So to do that, I'm going to do plus 2 to both sides first. And that'll get rid of my minus 2. And then I can bring everything else down. So the square root of x plus 1 comes down. The 2's gone, equal to 3 plus 2 is 5. And now that I have the square root isolated, I can go ahead and do the same thing I did in example 1 by squaring both sides. So that again will get rid of the square root for me, and I'm left with x plus 1 is equal to 5 squared, which again is just 5 times 5. So that's 25. And then I solve for x, so subtract 1 from both sides, which leaves me with x is equal to 25 minus 1 is just 24. And that's it so far. So these are the simple ones, okay, where usually you just kind of have to move something and then square both sides and then solve. The one I'm going to talk about next is a little more complicated, just a little bit, okay. So in this one, I went ahead and used that 1/2 property. Remember that 1/2 is the same as the square root. So if you need to rewrite this, you're welcome to. It's going to be 8, and then the square root of x minus 4 minus 2 is equal to 54. So all I did here is I rewrote this 1/2 with the square root, okay? So from here, it becomes similar to that second example where I have to isolate this square root, so I have to get this by itself. So before I do that, we're going to get rid of this 2. So plus 2 to both sides, and that will leave me with 8, the square root of x minus 4 is equal to 54 plus 2 is 56. Okay. And now I can go ahead and get rid of this 8. So to get rid of it, we need to divide everything by 8. So I divide this side by 8 and the right side by 8, which will give me a 1 here. So I can cross that out. And 56 divided by 8 is just 7. Okay. So I'm going to bring everything else down. And now it looks just like the first example that we did. Okay, so since our square root is isolated, there's nothing in front of it, behind it, or underneath it, I can go ahead and square it to get rid of that square root and square this side as well, which lets me cross this out here, bring down that x minus 4, 7 squared, remember this is the same as 7 times 7, so that's 49. Solve using algebra, so plus 4 to both sides, because we're trying to get the x by itself. So x is equal to 49 plus 4 is 53. And that's it. Still not too difficult, okay? So far we've done square root equations that have just one answer. Some of them require more work, like this one you had to isolate first. Example 2 you had to isolate first as well. And example 1 was just, square and then move a number. So what happens if we end up with something that has two answers? Okay, so here's an example of what I mean. Okay, we're going to go ahead and work out this problem now. The square root of 39 minus 10x is equal to x. So the first thing I'm going to do here is go ahead and square, because we want to get rid of that square root. Okay, so doing that leaves me with 39 minus 10x is equal to x squared. Remember that square just means x times x. So that means x times x, which is just x squared. Okay, now this one should look a little familiar because we kind of just went over factoring. Okay, so if I were to do some moving around here, I could end up with something that might be factorable. So I'm going to go ahead and do that. I'm going to take this term and move them to the other side, move them with the x squared, and see what happens. Okay, so if I move these over, I'm left with a 0 on this side. I bring down my x squared. Okay, minus 10x moved to the other side is going to be plus 10x. Positive 39, remember there's nothing in front, that means it's positive. Positive 39 moved to the other side is minus 39. Okay, and I'm left with something like this. Okay, this should look familiar. Okay, this is a quadratic. This is what we did in that factoring video. Okay, so remember, to factor, we have two sets of parentheses. We have an x in both parentheses, and then we're trying to find a number that multiplies to this, to our c value, and adds up to the b value. Okay, so just really quick, 39, I know that 3 times 13 is 39, and since it's negative, okay, I can probably make one of these negative. One has to be negative, one has to be positive. So if we do it this way, well, that'd be negative 3 plus 13. Let's see, that would equal to positive 10. So those are the numbers that I want, okay? So negative 3 plus 13. And just to double check one more time, so we see what we're doing. 3 times 13 is 39. One's negative, which makes it negative. Negative 3 plus 13 gives me that positive 10, okay? So these factors are correct. But I want the solution. I want x equals. So I have to take it one more step, and I have to solve. So x minus 3 is equal to 0. X plus 13 is equal to 0. And I solve. So in this side, I add 3 to both sides to get rid of that minus 3, which leaves me with x is equal to positive 3. And in this one, I subtract 13 to get rid of that 13. So I'm left with x is equal to negative 13. So my answers are x equals 3 and x equals negative 13. Okay, so we're done, right? Well, not quite. Here comes that extra word that we don't really like too much. You probably remember it from the absolute value equations. It's called extraneous solutions. Okay, so an extraneous solution is when one of the solutions even though it comes out algebraically, because of the property of the equation, it might not always work, okay? So we have to take this number and plug it back in, same with this one, and see if it comes out. So I'm going to go ahead and scroll down a little bit and rewrite this. We're going to check this, okay? So let me erase this last example. We'll get to it right now. And we're going to plug in these numbers and see if they work, okay? I do apologize about the video. I know it's a little bit longer than usual, but you know, it's got to get done. Okay, so we're going to check these answers. So my equation was the square root of 39 minus 10x is equal to x. Okay, so let's go ahead and check x equals 3. So for x equals 3, we get the square root of 39 minus 10. And all I'm going to do is I'm going to take this 3 and plug it into the x's. Okay, so 10 times 3 is equal to 3. We're going to see if this is true. Well, let's see. 10 times 3 is 30. So 39 minus 30, square root of that is equal to 3. Let's see. 39 minus 30, well, that's going to leave me with a 9. Okay, and we know that the square root of 9 is in fact 3. So this one is good. My first answer checks out. Okay, now I'm going to try it for x equals negative 13. So let's go ahead and try that one. So the square root of 39 minus 10 times negative 13, okay, is equal to negative 13. Well, I know that negative 10 times negative 13 is positive 130, okay? If you can't do that in your head, you know, you can use a calculator or just do it on the side. 13 times 10, 1 times 13 is 13, bring down that 0, okay? So 39 plus 130, we're going to do that now. 39 plus 130, this is the same as 169, okay? And we want to see if this is equal to negative 13. Okay, so let's go ahead and do that. Let's take the square root of 169, which is 13, okay? And you can see right away that these are not equal to, this is positive and this is negative. So that tells me that x equals negative 13 is in fact what we call an extraneous solution. Okay? So there might be a little bit of confusion here because you have been taught in the past that the square root of anything, doesn't matter what this is always going to result in a plus or minus some number. Okay, and there is a property that says that. However, because we're dealing with square roots, okay, this kind of goes back to what the graph looks like. If you don't remember, square root looks kind of like this, okay? It's kind of like a sideways parabola. So remember the quadratic? This one is our parabola, which is that perfect U, and the square root is the inverse, so therefore we're kind of missing that other half. So that other half is kind of like the equivalent to this plus or minus thing we see here. So because we're dealing with just 1/2, we're only going to consider the positive square root of 169. Okay? Hopefully that made some sense. If not, that's okay. Just, you know, remember that we're dealing with the positive square root in this case. So that leaves us with our final answer in this problem for this equation. Okay? For this equation right here, we have that our solution is only one number, it's only 3. So I'm going to go ahead and write that out. The solution for this one is just going to be positive 3. And that's it, because the other one was an extraneous solution.